Corindus, a Siemens Healthineers company and developer of vascular robotics, recently launched a new set of automated robotic movements in the Techniques series designed for the CorePath GRX system. I'm here today with Kate Drake, Director of Marketing for Corindus, to talk about how the software automation provides advanced device manipulation during complex coronary and peripheral procedures. Could you explain the new automated techniques now available on the CorePath GRX robotics system, and how are they helping the operator?
So these moves are called wiggle, spin, daughter, and constant speed. And each of these is designed for a specific device, whether it's a wire or a rapid exchange catheter, and has a very specific use case, all with the ultimate goal of improving efficiency and standardization of care in these procedures.
Can you briefly explain how the automated daughter movement can help with crossing narrow or calcified lesions?
Daughter was designed similar to a technique that is called daughtering today, which is a rapid linear back and forth, almost tapping motion of the rapid exchange catheter as you're trying to cross lesions. And so this tapping motion can really help to more effectively cross lesions when they might be calcified or they might be very tight lesions. And we've had some good success with this already in the field.
So the automated movements of the robot replicate manual techniques from highly skilled operators. Can you explain how this was accomplished?
We went into the field and we spoke with physicians and we asked them, how do you address these different parts of your procedure, whether it's navigation or crossing lesions, and what techniques are you employing with your hands in order to effectively treat these patients? And so we gathered that information. And then we went again into the field and we looked and physically saw what are they doing with their hands. So we went into procedures and you kind of watch them as they're doing their cases and can validate what they're saying is indeed what they're doing with their hands. And then we also had physicians measure what they're doing. So measuring things like the speed that they move devices, the rotational speed that they move devices, the torque that they employ when they're manipulating devices, in order to build the parameters of these automated movements.
Have you heard any feedback from operators about these new automated moves?
Very positive. We've been really excited with the feedback that we've received. Some of the physicians who've used it have even identified new use cases and possible benefits of the automated movements that we hadn't originally anticipated. So we're excited about that. We have about 6 installations right now globally. And now that we've received FDA clearance, we'll be rolling this out here in the USA. And we're really excited to get some additional feedback and see how this can be applied in clinical practice.
In sessions at TCT 10 years ago, I remember some of the luminaries discussing the CorePath system and its capabilities, and a lot of it was discussing 101 level entry PCI. But you've really reached a point now where you're going beyond this and you're going into complex lesions and also talking about telemedicine for telerobotic procedures.
We conducted our first in-human clinical study of remote PCI at the end of 2018 in India with Dr. Tejas Patel. He was 32 kilometers away from his patients, sitting at a Hindu temple, and his patients were in his hospital, Apex Heart Institute. And that was a great study to demonstrate the possibility of remote. A lot of people kind of always thought, oh yeah, that'll happen, but it'll be decades away. And that's not decades away, that's within this decade. And so that's really exciting for us because we have the ability to really transform care delivery in interventional medicine. And we are making good on those promises that you heard about 10 years ago.